Hey, what's up YouTube? Over the last 2 years, I have fell in love with building applications that have generative AI capabilities built in. But since this industry is so new and as foundation models evolve, developers face significant hurdles in keeping up with the changes while leveraging multiple foundation models effectively. Some of those challenges include things like model versioning, staying current with the various models, and the APIs, which requires constant learning and adaptation. Second, conversation management. If you ever built a large language model with a chatbot, you'll find that keeping up with the memory of those conversation dialogues adds an additional layer of complexity. Third, multi-model integration. Coordinating conversations across different AI models presents some real technical challenges. And lastly, API integration. Incorporating external data from APIs to enhance your AI responses requires some real sophisticated orchestration. Now, before we look at some code, let's take a high-level look into how AWS is solving some of these challenges. Now, when we talk about solving these challenges, at the core to easily build and scale your generative AI applications, we have Amazon Bedrock. This gives you the ability to have a choice of the foundation models that you want to use. It also allows you to customize your applications while integrating generative AI into your applications very easily with providing things like guardrails, using things like prompt management, and also selecting different large language models while having the ability to use agents within your applications. This is just some of the features that is in Amazon Bedrock. Now, when we talk about model choice, we have a list of providers that you can use within Amazon Bedrock. Some of those providers are Meta, with Llama 2 and Llama 3, Anthropic with Claude 2, as well as Claude 3 in the different model series within Claude 3. Those are just to name a few. Now, one way that Amazon Bedrock is really solving the challenges that I mentioned previously in this presentation is around the Converse API. This gives you that unified API to be able to communicate with all of the text generation models on Amazon Bedrock. What it does is it gives you that standard structure for your hyperparameters across those large language models while also handling your prompts for your requests and handling your responses, so you don't have to worry about structuring these for the different large language models or foundation models that you use on Amazon Bedrock. Another key feature is that it gives you the ability to handle your conversations within the Converse API. So you don't have to worry about on the side, you can use the array within the Converse API to handle your conversation memory. One last thing that I want to point out is that the Converse API gives you the ability to use functions or tools for those foundation models that support the tool usage. Now let's hop into our Jupyter Notebook to look at some code to see how it actually works. Now that we're in our Jupyter Notebook, you can find this in the description of this video if you want to follow along. I will also have a link at the end of this video where you can download this Jupyter Notebook and spin it up for yourself. Now, I kind of mentioned some of these challenges in the beginning. Amazon Bedrock with the Converse API solves these challenges that we discussed by providing that unified API. It handles your multi-turn conversations. It allows you to integrate seamlessly between your different large language models, and it provides that seamless tool integration. And we'll look at all of this here in the Jupyter Notebook. Now, some prerequisites is you're going to need an AWS account along with the AWS CLI installed on your system, Python 3.7 or greater, and you'll have to enable access to the foundation models that I have listed here. Now, let's go ahead and set up our Jupyter Notebook. The first thing we're going to do is install two different libraries. I'm going to get those started. That's going to install Boto3 as well as a library to handle our time zones at the end of this presentation when we do a tool example. So that installs our libraries. Now what we're going to do is import Boto3 along with JSON, and then we'll instantiate our Bedrock runtime. This allows us to invoke Bedrock as well as use the Converse API to Amazon Bedrock. Now, if you've been using Amazon Bedrock, you may be very familiar with the Invoke Model API. This still works great for image generation as well as for your single-turn conversations. But once you start to get into multi-conversations and using multiple large language models, that's where the complexity comes in. Let's actually take a look at the Invoke Model API. Here we have an example of how you would actually structure this. We're going to send a request or a prompt to the Claude 3 Haiku foundation model. But in order to do this, we actually have to structure the request in the form of the native API. So think about this. If you're using Meta Llama 3, you're going to have to structure this for that API. Now, in this example, we're using Claude 3. We have to structure it for that API. So if you're using multiple large language models or foundation models, this is where the complexity comes in, and I'll show you an example of that. Now, before we can send this native request to Amazon Bedrock, the first thing we have to do is dump this into JSON. If you're using something like C, this is where the complexity really gets in because you have to handle that within your code. Python makes it fairly simple to do this. We use the invoke model. We take our model ID. We have application JSON for the content type, except, and the body. And then we take the response, and then we have to load that JSON response. We take the body key, and then from there, we're going to output our response. The prompt that we'll send is, what is Amazon VPC? So we'll run this, and notice our response from Amazon Bedrock, the Haiku foundation model. Now, for one single foundation model, this works great. Here's where the challenge really comes in. If you have different large language models. So here we're going to send one to Anthropic Claude. This is the native API request for that. We have one for Llama 2. This is going to be the native API request for Llama 2. But also notice we also have to handle the prompt because the prompt needs to be formatted a certain way for this. And then the same for Llama 3. Again, this is the native request for Llama 3. And notice that we also have to handle the prompt here. Once we have these different if statements, what we're going to do is also handle the response from the foundation model. With Anthropic Claude, we're looking for the content and then the text because it uses the messages API of Anthropic Claude. But from Llama, we have to do the generate. So we have to handle both of these responses from those large language models. And now we take the models that we're going to use, create an array, and then from this array, we're going to use a for loop to ask the same question to each one of the foundation models. We'll run this, and we'll notice a response. So here we have our first response from Claude 2.1, and then we have one from Haiku. Now we have one from Meta Llama 2, and then we have one for Meta Llama 3. This worked great. Our response, everything is handled great. But what if we want to add a response from something like Mistral? Well, that's where the complexity will get even more challenging because every time we have to use a different provider or there's a change to a foundation model, we need to go back and update these if statements. And that could be some code that you have to manage that could cause some type of technical debt or break your application if there's something that changes. So in order to solve this problem, what AWS has done is created the Converse API. And if we take a look at the structure of the Converse API, this is how it's structured. So we have our initial message where we structure in a user assistant type format. So it alternates. So here we have our role of user, we have the context and the type of text, and we ask the question, how are you today? We take this initial message and we append it to our list. So now we have an array of messages for our user and assistant. But currently we only have our user. We'll see more of this in a moment. We have our response that we send to the Converse API. Notice our model ID, we pass that in. We take our message array and we assign that to messages. And then we have this inference config. Previously, we had to handle the native API requests for the hyperparameters for that specific API. But with the Converse API, we can just use the max tokens, the temperature for the Converse API. And if we need to, we can add additional hyperparameters for the specific model. This simplifies everything. And then the messages format is the same across all the models. And so now when we send our request, here is the response from the foundation model. And notice when I mentioned this alternating user and then assistant, here is the user message. that we append to the beginning of our message list array. And then from here, we have our assistants that we actually take that and we append that next in our messages list. Now with the Converse API, we also have the Converse API streaming. And what this allows you to do is stream your responses from the foundation model. Notice here we have a stream conversation where the format of the actual request is the same, except now we're using Converse Stream rather than just Converse. And then we pass in our model ID. We can even include a system message. This is another thing that the Converse API supports, is the ability to have a system message passed in natively into the Converse API. Then from there, we have our inference config. Now, what's going to be different here is the actual event that comes from the response of the Converse stream. What we're going to do is we're going to look for the start of the stream, and then we're going to take each chunk of that stream, and then we'll print out each chunk. Now, when we actually make this call to the foundation model, notice our streaming response. And since we're using Haiku, this is going to be blazing fast since it is the lightest and fastest model from Claude 3. And here's the streaming response. This lets us know the response started from the assistant. And then at the end, we'll have the metadata from the assistant response. And we're printing all this out. Now that's the Converse Streaming API. Okay, now what we're going to do is look at some additional features of the Converse API. Here we have a function where we're going to pass in your model ID, the prompt, and a system prompt of you are an AI assistant that specializes in AWS. From there, we already have our message list where we only pass in the prompt. So we're going to handle all this since we're just keeping this very simple. We have our system prompt and we're just passing the text for the system prompt. We have our inference config where we set the temperature to 1 and the max tokens to 256. And then finally, we're going to send our request to the Converse API with all of those parameters, and then we'll print out the response. Now, if we take a look at this unified API example, here's what the real power is. We create one function that has all of our hyperparameters and everything we need, and then we can just pass in the different models, IDs, that we want to send a request to. And so here, we're going to take each model, create an API call for each one of those models, and then we'll print out the response. So if we run this, notice that we have a response from Haiku, and then from there, we have one from Llama 3. And this is where the real power comes in with the Converse API, because now we have one function that can leverage multiple models, and you don't have to worry about changing those hyperparameters or adjusting the prompts for those particular models along with the responses. Now, I mentioned multi-turn conversations. So when we're using these models, one of the challenges that we need to address is the memory of those conversations. Oftentimes, this is going to be some extra code that you have to build and deploy and maintain for the structure of those conversations. And then if you're doing that across different models, that can be even more challenging. So to simplify this, the Converse API allows us to create a function where we just pass in the model ID in this example. We create a messages list. And so now in our chatbot, what we're going to do is have a user input. So I'll pass in a question, and then from that user input, it takes that and it adds it to our messages list. So now when we talk about the messages for the Converse API call, it needs to be user and then assistant and then user. It alternates. We're handling all of that within our code. So now I send my request to the Converse API, and then that response is going to be appended to our messages. And then we'll take a look and see how that actually works. So now when we talk about having conversations and the memory of those conversations, if I run this and I ask the chatbot, what is the Amazon VPC? We'll get a response from the model. And notice that this is my question, which is the user, and then this is the response from the assistant or the AI. So if I ask it one more question, what is AWS? Again, that's going to be user and assistant response. We get a quick response from the model, and notice we have the user and we have the assistant. Now, when we're using these foundation models, what if I ask it about the time or the date? What is today's date? Well, notice the response from the foundation model is that it doesn't actually have access to an external calendar or to the actual time because it has no temporal awareness, and it also doesn't have any APIs to be able to call by default. So what we can actually do is leverage something called tools or functions and provide that information to the foundation models and help it generate a response. Before we do that, let's exit our chat. And now when we exit this, one thing I want to call before we talk about tools is that here we have our alternating messages of user and assistant. So our first question is, what is the Amazon VPC? And then we have our assistant response. And then our second question was, what is AWS? And then we have our assistant response. And then lastly, I asked it, what is today's date? And then we have our assistant response. When you're using the conversation or memory within the Converse API, this is how you want to structure your messages in order to have them function properly within your chatbots. And so within the Converse API, you have the ability to use tools to be able to determine what's today's date, make an API call or a function call to get that date or time, and then pass that JSON from the API into your foundation model, and then your foundation model can generate a response. The first thing we're going to do is create the Bedrock client. And then from there, we'll create a function that gets today's date and time, and then formats it as a JSON so it can be sent back to the foundation model. Now, after that, what we'll do is we'll create a new function for the conversation. This conversation, the difference here is we're going to use tool config. So we take the tool config parameter, and then we pass in a JSON that has tools, tool spec, the name of the tool that we want to use, along with the description of that tool. And then this is going to be the input schema that the model can expect to be able to determine, okay, do you want the date? Do you want the time? And then send that to be able to call the actual tool itself. Now we set the tool choice to auto because we want the model to be able to handle this. And then we'll generate a response. Okay, just like in our last example of how we had our chatbot and we used a while loop to manage that, what we'll do here is we'll run our chatbot and then we'll ask the same question again, what is today's date? And so once we do that, we get a response from the AI, and I wanted to show you the entire response because I think this is really important to understand. So here's our question of what is today's date? And then we print out checking today's date, and then we have our response from our assistant. Notice that today's date is the actual correct date, August 26th. And this is because it used our tool of get date time. And this is how, when you're using tools and function, it actually works. So now when we ask our question and we process this response, if it's just a basic question, it's just going to print out the response. And so this time I'll ask it, what is AWS again? And notice that our chatbot would just print the response. But when we asked it about the get date time, it was able to recognize, okay, I need a tool for this because I don't actually have the answer within my foundation model itself. And so this is just a quick example of how to use tools within the Converse API. We'll exit this. Our conversation has ended. Now it's time for you to try it out for yourself. If you do not have an AWS account, I'll leave a link in the description where you can sign up and get started today, as well as get started with Amazon Bedrock and the Converse API. If you have any questions or comments, leave them in the comment section below. We hope you enjoyed this video. Please subscribe to the AWS Developers YouTube channel, and we will catch you on the next one. Happy building. Peace.